Okay, we are recording this for chapter 3.3, the derivatives of the trig functions. So all the derivative formulas, the basic derivative formulas, are in the textbook. So I'm not going to go over those. So what I'm going to do is I'm going to take one example of a product rule involving a trig function or two trig functions, and I'm going to take one quotient rule again involving a trig function or two trig functions. So let's take a look at this first one. Let's take a look at y equals the sine x times the cosine x. Okay, again, product rule. So we've already covered the product rule, so you theoretically already know what the product rule is. First times the derivative of the second plus the second times the derivative of the first. Okay, so that's exactly what I'm going to do here. If there's any simplifying or factoring, I will also do that, but in this case, I don't think there's going to be. Let's take a look at this, y prime. First, which is the sine x, times the derivative of the second, which is minus sine x, plus the second, which is the cosine x, times the derivative of the first, which is the cosine x. All right, so this is the raw derivative before I've done any kind of cleaning up or factoring, but there's really not going to be any factoring here, just a little bit of cleaning up here. All right, so I'm going to consolidate my terms here, and I'm going to rewrite this as y prime is equal to minus sine squared x plus cosine squared x. So there's really nothing else we can do with this. I mean, yes, we could make a Pythagorean substitution here, but that's really not going to do much for us. That's about as clean and as simplified as you could possibly get this. All right. So there's the first one. Now, again, all of these trig formulas are in the book. So there's no sense in me going over those because everybody has access to them. You don't really have to memorize them because you have them right in front of you. So now let's take a look at one of these involving trig functions, but instead of a product rule, let's take a look at one that involves a quotient rule. All right, so let's take a look at y equals the sine x divided by the cosine x. Now, some of you might recognize that this is actually the definition of the tangent x, but I'm going to go through this anyway. Okay, since we should know that the outcome for this is simply going to be y prime equals secant squared x, because that's what the derivative of the tangent is. So in a sense here, we're actually deriving the formula for the tangent. Now, I'm not necessarily going to ask you to do that, but this kills two stones with one bird because we're looking at a quotient rule, we're doing some simplifying, and we're coming up with an answer that is actually one of the basic derivatives. So let's take a look at a quotient here. Y prime is equal to the denominator, cosine x, times the derivative of the numerator, which is cosine x, minus the numerator, which is sine x, times the derivative of the denominator, which is minus sine x. And that's all divided by the denominator squared, which is cosine squared x. All right, now again, language. This is what the raw derivative looks like. All right. Again, starting with the denominator. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So I'm going to clean up that numerator now. So the numerator is going to be rewritten as y prime is equal to cosine squared x plus sine squared x, all divided by cosine squared x. All right, so simplifying the numerator, I get cosine squared plus sine squared, but of course, everybody should recognize that as being our basic Pythagorean identity. So cosine squared plus sine squared is actually equal to 1. Again, that's the Pythagorean identity. So I'm going to rewrite this as 1 over cosine squared. So this is equal to 1 over cosine squared x. But 1 over the cosine squared, since 1 over cosine is equal to secant, then y prime is equal to secant squared. Again, because 1 over cosine by definition is the secant, then 1 over cosine squared is equal to secant squared. So I have y prime is equal to secant squared x. And if you look at your basic derivative formulas, you will see that we started up top with sine divided by cosine, which by definition is the tangent. And you will see that the derivative of the tangent, in fact, is equal to the secant squared. Now, it's true, I'm not going to ask you to actually derive these formulas, but here I am showing you how the quotient rule works with trig functions, how to do some cleaning up, how you should know how to use the Pythagorean identity, because that's used quite a bit. In fact, there are several Pythagorean identities that you might need to know. They should be in the book. And cleaned up and simplified, we actually see that the derivative of the tangent is equal to the secant squared. Okay. So in addition to the 6 derivative formulas for the trig functions that you see in the book, you should also pay attention to the graphs of these, and you should also have a little bit of information available to you, either from what you remember or maybe what you are going to learn, reviewing your pre-calculus, what the domains of these functions are. Because some of the trig functions, like the secant, has vertical asymptotes. In other words, they are not defined everywhere. And that's going to play an important part, not right away in Calculus 1, but somewhere down the road when we get to the first and second derivative tests. Okay, so hopefully some of you are actually using some of these recordings that I'm making. right? They are, they are brief. This is not what a full lecture would actually be like, because it would be interaction, okay, between myself and the students and them having homework questions on stuff. We miss that unless you attend the Zoom sessions, which not many people are actually doing that. Okay, so I'm going to stop this recording.